Hello viewers, so in this very first video of mine, we will be starting to discuss about some of the process simulation conducted in Aspen HYSYS. And for our very first case, we will be discussing a rather simple one. The process is about the hydrogenation of nitrobenzene to produce aniline as the main product here. For the PFD itself, we refer to the Journal of Design and Simulation of Plug Flow Reactor and Distillation Column for the production of aniline via nitrobenzene hydrogenation. This is the original PFD, but we also make several modifications as some of the parameters set in here or the design might not be suitable for a direct use as there are missing parameters or variables that is needed to run the whole simulation. But the whole design or the whole general thing is kept the same. Okay, so moving back on to the PFD that we have completed. This video will serve as the basic introductory session for what we will be discussing in the upcoming videos, and we'll be diving deep into each of the parts, starting from the mixing, heating, and then the chemical reactors, separators, and also the distillation column, and even the recycle here in the upcoming video. So we will split it into some section. But this video, I will explain the general terms of what we will be covering here. So as from the journal, the raw material that we use is nitrobenzene at room temperature, around room temperature of 24 degrees Celsius, and the pressure is about 1 atm. And we do preheating to this nitrobenzene, and you will know the reason why in the next step. But the overall thing is that we will mix the nitrobenzene stream with the hydrogen, mainly the hydrogen. Just focus on the NBZ and the H2. For the recycle, it's the end product of the simulation. Okay, and then when we mix this feed, it will create a temperature of around 169. Okay, and from the journal, it is required that we make the reactions condition around 300 degrees Celsius at a pressure of about 1 atm. And this is the reason why we need a preheating, so that the burden of the heat exchanger of E101 will not be that heavy as we have done a preheating for nitrobenzene alone, because this one has the highest heat capacity. So more energy is needed for this stream. Okay, now that we have reached the feed, the required feed condition, we'll be using a plug flow reactor, because the whole composition and the whole phase of the mixture is indeed a vapor, a gaseous phase. Okay, it's a complete gas. Now we use the PFR because it's more suitable for a gas-gas reaction. And keep in mind that the reaction will occur isothermically. Isothermically. So there will be some Q generated from the reactor, as the reaction is a highly exothermic one. And then from the outlet, will be cool it down, so that we can separate it. Well, you can say like a flash drum, but not really a flash drum. Where we'll be separating the natural gas phase of the mixture. And from the composition here, we know that we have only 4 components: hydrogen, nitrobenzene, aniline, and H2O. And the only thing that is in a gas phase at near room temperature and condition is the hydrogen. That's why we use the flash tank, you can say. And keep in mind that for the sake of simplicity, we use a lot of assumption for this PFD. There are no side reaction, there are no waste material, there are no secondary product or else. It's just a complete one-sided reaction with the overall conversion of around here 31.89%. Okay, now the bottom product of the flash tank, yeah, flash drum, will be, yeah, basically only three components: nitrobenzene, aniline, and water. And because we know that the component that has the highest boiling point is nitrobenzene, that means for the first distillation, we'll be separating nitrobenzene from the rest of the effluent, yeah, effluent. Okay, so from this distillation, we know that, yeah, from reading the composition, the top product will contain, well, you can say practically no nitrobenzene, or around 2.9%, almost 3%, while the bottom product, the bottom product, it will only contain almost pure, yeah, pure form of nitrobenzene, 99.97%. And that is the exact reason why we can do a recycle here, because the purity is already very high. That means we do not need a lot of further process to mix this feed into the mixture, yeah, into the mixer here. That's the reason why we can directly have the stream connected to the initial inlet. Okay, now for the top product, we'll be having only now two components: aniline and H2O. Aniline as our main product, and H2O our uh, as our also from the reaction here, okay. We know that aniline has a boiling point of around 184 degree, while H2O is just a standard 100 degree, yeah, more or less. So this distillation column, the second one, will serve as the, you can say, the separator and the purifier for our main product, which is aniline. You can see here that the purity, composition, well, we can use the mole fraction, yeah. Okay, so there are still some impurities, which is mainly water, but the main product is still the aniline of around 78%. Well, for the top product, yep, here you can just use the mole fraction too, it's okay. Yeah, the top product is almost completely water with very little aniline in it. And there you go. This is the very basic process flow diagram. It's just for a entry study. It's just for knowing, yeah, the interface of the program that we use, and also some of the logics that we have in order to make this process happen. And this is for the first introductory video. For the next video, we'll be diving into the specification for each of the reactor more detailed. So thank you, and stay tuned for our next study.